The elimination method is another way to algebraically solve systems. And the point of the elimination method is to eliminate one of the variables. We first want to make sure that the equations are both arranged so that they line up vertically. We want the x's to line up, the y's to line up, and the numbers to line up. Then you're looking for one of your variables. You want one of the variables to match with one of them positive and one of them negative. Like in number 5, notice we have positive y and negative y. The reason we want them to match but be opposites, we're going to add these two equations together. So if we add these straight down vertically, x plus 2x is 3x. Y plus negative y is 0. And 7 plus 2 is 9. By adding these two equations together and eliminating one of the variables, we now have an equation that we can solve. And usually it's an equation that we can solve fairly easily. So if 3x equals 9, that means that x equals 3. Some people really prefer the elimination method because it seems like you get one of your answers a lot faster than you do using the substitution method. Now, if we wanted to, we could definitely use the substitution method here. We would have to subtract x on both sides and then substitute and then solve. You would still get the same answers. It's just another method for doing this. Once we know that x is 3, pick one of your equations. And be strategically lazy. If you don't want to have to deal with minus y, don't deal with minus y. Pick the equation that doesn't have that. So pick this equation, and we know that x is 3. So we can plug that 3 in place of the x. So y equals -1. The solution to this system is the ordered pair 3, -1. This particular system is set up perfectly for elimination, so it makes sense to use the elimination method. Sometimes the systems are not set up perfectly for elimination, and it would honestly make more sense to use the substitution method. It really depends on which method you prefer. If you constantly get the wrong answers when you use the substitution method, then you should probably not use the substitution method. On number 6, we aren't actually going to do number 6, but I want you to notice what you would have to do. Is there something wrong with number 6 right now? The things need to line up. So right now, the x's don't line up, the y's don't line up, and the numbers don't line up. So you would have to rearrange this equation. Mainly, you'd have to rearrange the second equation so that it had the x first, and then the y, and then the 8 on the other side. Okay, let's look at number 7. Number 7 is actually set up nicely for elimination, but we have to do something before we eliminate. So if I were to add these together right now, I would get x plus 4y equals 8. Nothing would eliminate. So before you add them together, you first need to make a plan for how am I going to get one of my variables to eliminate. And I noticed that I've got 3y here, and I've got this just plain y on the top. So, is there a way that we could turn this one into a -3y? Multiply the top equation by -3. That would give us -9x minus 3y equals -18. And then it's usually a good idea to recopy the other equation underneath as well. Before you actually add the two equations together, stop for a minute and check. If I added these together, would my y's eliminate? So look here. We've got negative 3y, positive 3y, so we're good. Now, do you always have to eliminate the y's? No. If the x's look like they would eliminate easier, do the x's. Do you want to finish this example, or should we move on to example 8? Move on to example 8. I want you to see example 8, how to start example 8. So note, this example is not finished. You would need to then finish it. Yeah, that does look kind of weird. Okay, so number 8. If I were to add these two equations together right now, nothing would eliminate. So we need to make a plan. First, we need to decide, are we going to try to eliminate the x's, or are we going to try to eliminate the y's? Do the x's or the y's have smaller numbers? The x's. I would say go for the smaller numbers whenever possible. That's my strategic laziness coming out. But when I see 2 and 3, what number pops into your head when you think of 2 and 3? 6. So would it be nice if instead of 2x and 3x, if this was 6x and negative 6x? So that's going to be our goal. We want the top one to be 6x. We want the bottom one to be negative 6x. So on the top, how would we make 2x become 6x? Multiply by 3. So I'm going to multiply this entire top equation by 3. And don't forget, it's basically distributing. You have to multiply every single term by 3. So 3 times 2x is 6x. 3 times 4y is 12y. 3 times 3 is 9. Okay. On the bottom, we want this 3x to turn into negative 6x. What do we multiply by to make it turn into negative 6x? Negative 2. Negative 2 times 3x is negative 6x. Negative 2 times 5y, negative 10y. Negative 2 times 1, negative 2. Now, if we check our x's, they will definitely eliminate. So add them together. 6x and negative 6x is 0. You don't even need to write that 0, but you certainly can. 12y plus a negative 10y is 2y. Solve that. 7 divided by 2 is 3.5. I think 3.5 is easier to put in the calculator than 7/2 is, so I'm going to leave it as a decimal. Okay, what should I do now? Plug it back into the original equation, and it does not matter which original equation. So I am going to pick 2x plus 4y equals 3. If you wanted to pick the other one, you could. So 2x plus 4 times 3.5 equals 3. 4 times 3.5 is 12, 13, 14. So 2x equals negative 11. So some may think that substitution would actually be easier for this problem, but with substitution, you would have had to solve one of those equations for x or for y, which would involve dividing by some number and probably give you decimals or fractions. So even though it takes a little bit of work to get this set up and ready for elimination, it is still less work than substitution. Now, the stuff we talked about yesterday, sometimes when you're doing one of these systems, like, you don't have to write this down, but say you had like something like this. You added the system together, you'd get 0 plus 0 equals 16. If both of your variables eliminate and you're left with a false statement, it still means no solution. If both of your variables eliminate and you're left with a true statement, that would be many solutions. So the stuff we talked about yesterday, when everything goes away, that still stands.